2 is a very conceptual question concerning the differentiability of absolute value of x versus the differentiability of x squared times the absolute value of x at x equals 0. So what we're told here is we're supposed to use the limit definition to determine why this is not differentiable, but why this one, x squared times absolute value of x, is differentiable. So remember that you have two forms for your limit definition. You can use the x plus h definition, or if you know the specific point, sometimes it's easier to use the x and a definition, which would be f of x minus f of a over x minus a. That's the limit as x approaches a. So that's what I'm going to use here. And we were told that we're evaluating the differentiability of these at 0. So our a is 0 for here. So let's start with absolute value of x. So when we use this function here and we plug into this formula, we're going to end up with the following. So we're going to do limit as x approaches 0 of absolute value of x minus, so f of a is what do we get when we plug in 0 to absolute value of x? Well, when you take absolute value of 0, you get 0 over x minus 0. You can see this simplifies to the limit as x approaches 0 of absolute value of x over x. So here's the problem. First of all, you can't plug in 0 to this because you get an indeterminate answer because you get 0 divided by 0. So in order to evaluate this limit, we would really have to do x approaching 0 from the left and from the right. So let's figure out what those limits are. So let's start with limit as x approaches 0 from the right of absolute value of x over x. Well, if we know that we're doing 0 from the right, that means we're only considering positive values of x. So if we know x is positive, then this absolute value bar, or the absolute value function, is just x, because we don't need the absolute value bars anymore. So this would just be x over x, which is 1. And similarly, if we did the limit as x approaches 0 from the left of the same function, now we know we're only choosing negative numbers for x. Well, if we're only choosing negative numbers for x, absolute value of x can just be rewritten as minus x. Minus x over x gives us negative 1. So the limit from the right was 1. The limit from the left was negative 1, which means the limit as x approaches 0 in general does not exist. So this one does not exist, which tells you that this function is not differentiable at 0, because when we did our limit definition of the derivative, we got a limit that does not exist. So therefore, it's not differentiable at that point. So let's try that with x squared times absolute value of x. Again, we're using this formula. So I'll write that one down here. Again, we're evaluating it at x going to 0. So our function f of x is x squared times absolute value of x. F of a, again, is what do we get when we plug in 0 to this function? Well, we get 0, just like we did on the previous one. All over x minus 0, according to that formula. So the minus zeros don't matter. So let me just get rid of that here, and you can see this fraction. So we end up with this following fraction, x squared times absolute value of x over x. And one of our x's can cancel. One of the x's in the numerator can cancel out that one in the denominator. So this is just x times absolute value of x, because we're canceling like that. Well, now when we take the limit as x approaches 0 of this function, there's nothing that's making that indeterminate. So we could just plug in 0, and if you plug in 0, you get 0. So this limit is actually just 0. Again, we don't have to do the left and right sides because we didn't get anything that was indeterminate in the first place, but that's what we got here. That's why we had to do that. So by the limit definition, using x approaches 0, for absolute value of x, we get an indeterminate form, and when we do the left and right, they are different, and we get does not exist. for x squared times absolute value of x, when we use the limit definition, we get a simple limit that we can evaluate. Does exist, so that's how you know that absolute value of x is not differentiable at 0, but x squared times absolute value of x is differentiable at 0.
The Teaching Center, UF's Learning Resource Center.